I'm going to show two solutions to this question. There's a very simple solution, and then there's a way that I did it, which is unnecessarily complicated, but it did get me the correct answer. It's interesting to contrast sometimes, how complicated you can make it, and how simple you can make it. So we're told that the length of the diagonal of the large square is 10, and this one is 8. Okay, so it's definitely worth drawing them on. Now here's the thing, because this is necessarily 45 degrees, because it splits it into two congruent triangles here, this is also 45, and the same goes here. And once you realize that, basically done. You have a 90-degree triangle here. If I draw it out like this, I've got 90 degrees, 10, and 8, and I can work out the area of the big triangle. It's just a half times base times height, or 40. And we're not quite done, but because P is the midpoint of XQ, because it's the center, then it must be that these two triangles are the same or congruent. And so we just need to take our 40, divide it by 2 to give 20. Okay, method 2. A lot more work in. We'll get to the right answer. Interesting to compare, but not the best method, it's got to be said. So first thing is, whenever you know, like this is x, for example, when you have a 45-degree triangle, it follows that this is x over root 2, and this is x over root 2. You can use Pythagoras' theorem to prove that, because you could say that 2y squared is equal to x squared, therefore y squared is x squared over 2, and therefore y is x over root 2. So that means that this length here is 10 over root 2, as is the height. And this here is 8 over root 2, as is the height. Okay, my method now actually involves compound area. I'm going to find lots of areas and add some, subtract some, and manage to find the answer. So this length is going to be half of 8 over root 2. It's going to be 4 over root 2, which means I can to get this red area here, I think I'll start shading it. It's going to be 4 over root 2 times 8 over root 2, which is going to be 16. And this green area is going to be 4 over root 2 times 10 over root 2, which is going to be 40 over 2. It's going to be 20. Okay, and then I can work out this triangle, which is going to be a half base times height. So a half times, this is going to be, I didn't add it, but this is also going to be 4 over root 2. So a half times 14 over root 2. And then because this is 4 over root 2, it's going to be 6 over root 2. So I'm going to halve the 14 to 7. This becomes 2, so it's going to be cancel out with that to give 3. So it's going to be 21. And then one other one that I can find, just realized, is this one here, which is going to be a half times 4 over root 2 times 4 over root 2. So the half, the root 2, and the root 2 are going to cancel with that 4, so I'm just going to get 4. Okay, so if I can work out the area of the two squares, subtract all these areas that I've found, and this one here, which is going to be the trickiest bit, and add on this bit, then I'm done. Right, now these triangles are a bit trickier, but I could extend this one, and actually I've got two similar triangles. I've got like a long length of 18 over root 2, and I've got a long height of 2 over root 2. Then I'm going to call this length here Actually, I'm going to call it x over root 2 because I know I'm going to get a root 2 involved. Um, and then for this smaller one, I've also got that this is 10 over root 2. So I can divide the height of the smaller one by the height of the larger one. And that's going to equal the the length of the smaller one, which is 10 over root 2, divided by the length of the larger one. So I can actually cancel out all these root 2's, and I'm going to get x over 2 is 5 over 9, and therefore x is equal to 10 over 9. So I've actually got 10 over 9 over root 2, and then it's going to be 11. This one here is actually going to be, oh, sorry, 8 over 9. It's smaller. 8 over 9 over root 2. Yeah, I'm sort of running out of space. I'm going to do it in red. So the area of this triangle here is going to be a half times that 10 over root 2 times this height, which is 10 over 9 over root 2. The half is going to cancel with the 10 to leave me 5, and the root 2 and the root 2 are going to give me 2, so I'm going to get 5, so I'm going to get 25 over 9. The area of this red triangle. And then there's just one more I've got to find. It's this bit here that I'm going to have to add on. So that's going to be a half times 8 over root 2 times 8 over 9 over root 2. The half, the root 2 and the root 2 are going to cancel with the 8s, leave me 2, so I'm going to get 16 over 9. Okay, I'm nearly there. So the area, or the shaded area, I should say, is going to be the area of the two squares, which is going to be 10 over root 2 times 10 over root 2, which is 100 over 250, plus 8 over root 2 times 8 over root 2, which is 32, plus this extra little bit that I've just calculated, which was 16 over 9. And now I'm going to minus all these other areas that I calculated. Can't believe I'm still going with this, but this is honestly how I did it. So the green area was 20. Do you know what? I'm going to add them all up separately. So 20, then we've got the red area, 16. Got this purple area, 21. Got this black area, which was 4. And then just that little triangle that I needed to subtract, which was 25 over 9. That gives, this is 1 and 7 over 9, so I'm going to get 82, 83 and 7 over 9 minus, here I've got 20, these are 20, 40, 61, and then this is, let me just write it down, 61, this is actually 2 and 7 over 9, so it's going to be 63 and 7 over 9. And we're going to get there, 20. So that is how not to do this question, but it does work. Both give answers of 20. Strongly advise going with this method, but I wanted to talk through this other method as well. Because, sometimes things won't work out quite as easily. This is a math challenge, and that often the questions, there are simple solutions, but sometimes there's not. And the fact is, you could use compound area to do this question.